When you have an exponential function that is in the form of y equals ab to the x, you are able to convert it into the form of y equals ae raised to the kx. To do this, you need to set the following equal to each other. You're going to take b and you're going to set it equal to e raised to the k and then solve for k. So let's look at some examples. We're going to take each exponential function that is in the form of y equals ab to the x, and we're going to convert it to the form of y equals ae raised to the kx. We're also going to state the annual rate and the continuous rate for each function. So let's start off with this one. F of x equals 72 times 1.05 raised to the x. So we're going to convert it into the continuous form, so I'm going to take what's in the parentheses, 1.05. I'm going to set it equal to e to the k. Now I'm going to solve, and it's very easy to solve. I'm going to take the natural log of both sides so I can get the k down and get rid of the e. So I'm going to have ln 1.05 equals k. Now we don't really like it to be ln 1.05, so we actually just put in a calculator, and we're going to end up getting to 3 decimal places 0.049 for k. And again, convert it to a percentage just by multiplying it by 100. We're going to get 4.9% equals k. So our function in this form, ae to the kx, is going to be y equals 72, because that doesn't change, e, because it's just a number, 0.049 x. So here is the form of a continuous function from this exponential function here. Now, we already know what the continuous rate is, which is k equals 0.049, and the annual rate which we get back from here, where b is 1.05, so doing b minus 1, so 1.05 minus 1 is going to give us r equaling 0.05. And you can see between the continuous and the annual rate, they're pretty close to each other. Sometimes they're always really close, sometimes they're a little bit further away. It all depends. So there's the annual continuous rate and the continuous exponential form for this example. Let's do it again for this one. G of t equals 33 times 0.92 raised to the t. Even though it's a t, it's okay. We're fine with that. T or x, it's all the same. So first things first is we are going to convert it. So again, I'm going to take my b value, 0.92. I'm going to set it equal to e to the k. And then take the natural log of both sides. I'm going to end up having ln of 0.92 equals k. And again, putting this into a calculator to get a number, I'm going to end up getting to 3 decimals, negative 0.083 for k. And again, as a percentage, it's going to be negative 8.3% for k. Now, to write it into my continuous exponential form, I'm going to get g of t equals 33, because the number stays the same, e, because that's just what's there, negative 0.083 t, because they use t instead of x. So there is my continuous equation, and now I need my annual and continuous rate for each one. So my continuous rate, which is already been done, is k equals negative 0.083. And for the annual, we just take b, which is 0.92, and subtract 1. And so I'm going to end up getting a negative 0.08 for r. So there's my annual rate, and there's my continuous rate. Last, y equals 14 times 2.01 raised to the x. So converting this into the new form, I'm just going to take b, which is 2.01, and set it equal to e to the k. Take the natural log of both sides. Ln of 2.01 equals k. Natural log of this to 3 decimals, I'm going to end up getting 0.698 equals k, which again, as a percentage, if you want it, just multiply by 100, is 69.8% for k. Now I'm going to write this into my continuous form. So y equals 14 because it stays there. E and k is 0.698 x. There is my continuous form. Now what is my continuous rate and annual rate? As always, the continuous rate's already been done, so it's just restating it. And that's just going to be k, so k equals 0.698. And the annual rate, just 2.01 minus 1 is going to give me r equals 1.01 for my annual rate. And in this case, you can see that the annual rate and the continuous rate are fairly far off, whereas the other two were decently close to each other.